Alrighty guys, so this is our first video for our new unit, and we're gonna have a very short unit, okay? And I'm kind of combining two separate ones into one unit and just picking out the highlights that I think are important for you all to see. Because as you know, we only have 1 week left of the second trimester. So this unit's going to be on perimeter, circumference, and area. That's what this lesson's about. And then the next days we're going to look at surface area and volume. And I picked those three kind of topics out because as far as most things we're talking about in geometry, they're probably the most applicable to the real world. You can use these in real life all the time. And also, the ACT loves to ask questions about perimeter, area, surface area, and volume. And so I want to spend time on this because it's so important. And a lot of this should be familiar to you, so hopefully nothing's too new. I'll tell you in this one, what I'm going to do is I'm going to make two separate videos because I don't want this video lesson to be so long. So the first video is just going to be on squares, rectangles, triangles, and trapezoids. We're going to look at the perimeter and area of those. Okay, I'm going to leave circles for their own video because they're totally different. So they're going to get their own video. You'll need to watch both videos so that you get all the notes taken, and then you can work on your homework. Your homework, I think there's like 22 questions. The first 10 are about these kinds. Okay, the second half is all about circles. Okay, so let's get started. So hopefully you remember what perimeter and area are. And I put circumference here because perimeter is not called perimeter when we talk about circles because perimeter deals with straight sides, so straight lines. Obviously circles aren't that way, so we call circumference for circles. But anyway, for perimeter or circumference, we can think of it as the distance around a figure. And I'm sure you've done this in middle school before. You know all the sides of a shape, so you add up all the sides, and that's perimeter. And so we can tell ourselves this is one dimension. That's important to remember because we're going to deal with units in area. So you'll have feet or feet squared, or when we get to volume, feet cubed. And it's important to keep the units appropriate for the problem you're talking about, okay? So if I say perimeter or circumference, that's one dimension. So that would be feet, yards, inches, centimeters, just one unit, nothing squared, nothing cubed, okay? Area is when you get to the second dimension. And so we think of area as space inside a figure. So this will be 2 dimensions. Which if you think about a square or a rectangle, will be length times width. Those are the 2 dimensions that would be there. The dimensions vary based on the figure you're talking about, but the area is always 2. Okay? So we're going to look at squares, rectangles, parallelograms, trapezoids down here, and triangles. Okay? You should have seen all of these before, I think, at least in middle school, possibly. So hopefully this isn't too bad. Okay, so a square. All you really need to know for a square is one side. That's why there's this little A right here. But if you wanted to, you could go ahead and label all the sides. They're all A, because we know all sides on a square are the same length. And so for perimeter, which we'll label with a P, we know that we could add all those up. A plus A plus A plus A. And you could write that out if you wanted to. 4 A's. But listen to what I just said. If you write that out, that would be 4 A's. There's a shorter way to write that. So instead of writing A plus A plus A plus A, we just put 4A. So that is how you find perimeter on a square. 4A. A being the side. Area. Of course, we know that a square is just like a rectangle, so the area would be length times width, but that would be A times A. Well, we can write that shorter. We know how to simplify that. We're just going to call it A squared. So you can use either one of these to find area. Just do A times A or A squared, whichever one you want to do, whichever one you want to use. Okay? A rectangle, well, now I know you all know this one. Everybody knows this one. All you need is the length and the width. But we know that this length and this length are the same thing. I did a cursive though, that's what that is. So these two sides are the same length, and these two sides are the same, so we can call that W. And so perimeter, you could do 2 L's plus 2 W's. Now we can write that other ways too, if you wanted to. Instead of writing it all out and typing it on our calculator, I always think of this: 2 lengths plus 2 widths. That's what I tell myself. All right, but either way you want to think about it is fine. But I prefer this one: 2 times length plus 2 times W. Also, a quick note here. Sometimes, depending on who's writing the textbook or the problem, instead of being length and width, you could see base and height. So you could see B and H here. And it still works the same way. For some reason, with rectangles, we like to use length and width, and then for other ones, we use base and height. But if you see that, just remember they're the same thing. Now, area, I shouldn't have to tell you this. Everybody knows this. This is length times width. Everybody knows that. All right. Now, as far as for parallelograms, triangles, and trapezoids, there's no real formula for perimeter per se. So you have to kind of rely on the definition of perimeter, which means you add up every single side length. So my note for this, for perimeter, we're just going to say add up all the sides. Okay, so for that one, for this one, and this one. So parallelogram, triangle, trapezoid, as far as for area or for perimeter, just add up every single side length. And hopefully you know all the side lengths of those figures, or it's easily, I didn't say that right. It can be found easily to find all the sides, okay? And we'll see that in a minute. But now, these three have their own area formulas, so that's what I want to talk about here. So on a parallelogram, you're going to have a base labeled and a height labeled. And actually, for all three of these, you're going to have bases and heights. The thing to remember is heights, the H's, are always straight. And sometimes they're inside the figure or they could be outside. But remember, they're always straight. Okay, they're not angled or they're not diagonal like this. They're always straight up and down. And they will always make 90-degree angles. See, every time, they're always 90-degree angles. That's your clue to figure out who the height is, okay? Now, the area formula for a parallelogram is simply base times height. It's just like the rectangle, but instead of length and width, we say base and height, okay? A triangle, you should know this one. This is 1/2 base times height. Okay, and if we had time, I would prove to you where these formulas come from, but we don't have time, so I might post a supplementary video of like, hey, just in case you want to know, this is how we do this, or this is where it comes from, but We're not going to focus on where they come from. I just want you to be able to use the formula. All right. Now, trapezoid's formula, area formula looks a little different. That is a terrible A I just wrote. Okay. It's sort of like a triangle's formula, but it's a little bit different. So it actually starts out 1/2, and actually we usually put the height first. Because instead of just doing one base, you've got two different bases to think about, and usually they're different lengths. So we say base 1 plus base 2. Okay, so it's 1/2 times the height times base 1 plus base 2. And again, if we had all the time in the world, I would show you where this formula is coming from, but we're not going to, so we'll just use it. So these are what you need to know, okay? And it's probably a good idea to commit these to memory. I would memorize these formulas because, especially on something like the ACT, they will not tell you these formulas. They're not going to tell you that the area for a square is a squared. They won't tell you length times width. They expect you to know them, okay? So you need to memorize these as best as you can. All right, let's work some of these out. Okay? So I've got a square, a rectangle, a parallelogram, a trapezoid, or triangle, and I did 2 trapezoids just because they're different. I wanted you to see 2 different versions of those. All right, so for a square, in every one of them, we're doing perimeter and area. Okay, so perimeter, we know it's a square, and every side is 8.5, so I'm simply going to do 4 times 8.5, and that will give me 34 feet. You simply just type that in. Type this in the calculator. And notice, remember, perimeter is one dimension. It's just feet. It's not feet squared, okay? Area, now I need to do the side times the side. So that's going to be 8.5 squared. And when you type that in the calculator, it's 72.25 feet. And now this one is where the squared comes in, okay? So on perimeter, just feet or centimeters or yards, whatever. On area, it's got to be units squared, okay? And I'm expecting you to put this for your answers, okay? You've got to get your units right. All right, rectangle. It's all right to label, so I would call this one the length and this one the width. I generally like the lengths to be longer. I don't know why, but it really doesn't matter. If you want this one to be length and that one to be width, that's totally fine. Does not matter. So remember, it's 2 times whatever one you want to call the length plus 2 times the width. And then we just type that into the calculator, and we get 28.4, and use our units. This would be kilometers. Or kilometers, I guess you could say. But kilometers is how you actually pronounce it. Area is length times width. We type that into a calculator, we get 38.85 kilometers squared. Okay, because it's an area problem. Kilometers squared. Now, I'm not showing how to type this in the calculator because I obviously you can do that. Here's where these formulas might be a little bit more unfamiliar. So we have a parallelogram here. And so remember, for perimeter, we just add up the outsides. Okay, remember, perimeter is the distance outside, okay? On a perimeter problem, especially on these figures, Do not use anything inside the figure for perimeter, okay? That's okay. I'll get to that in a minute. Okay, so we're just going to go on the outside edge of the shape. So I see a 10 plus 19 plus 10 plus 19 equals, and we add all that up, we get 58, and this will be yards. Okay? Now I want to stop here for a minute and make a point. Okay? Sometimes on a parallelogram problem, they might leave one of these sides out. So you might just see that. Okay? You're thinking, well, how am I supposed to find the other side if I don't know what it is? Well, parallelograms are kind of like rectangles in that the sides across from each other are the same length. So see how both of these are 19 and they're across from each other? So that means that this one labeled 10 and the one I'm covering up with my finger is supposed to be 10 also. So this one I was nice and gave it to you. But just know that sometimes you won't have that. Okay? It might be marked out. And so you have to recognize that this one labeled 10 and the other one that's blank are both 10. So just a note there. Now area. So here's what could go wrong with the parallelogram problem. You'll get the base and the height mixed up. So here's what I tell myself. The height is always straight up and down. It's not crooked. So it's not going to be this 10 and it's not going to be 19. It's actually going to be this one inside. That's the height. And notice that it is straight. Like if you turn this another way, this would be straight, and it's making a 90-degree angle with a side. That's how you know I'm covering all that up. I'm sorry. This 7.8 is straight and it makes a 90-degree angle. That's how you know it's the height. Now, which one's the base? Well, the base is whichever side the height touches. Okay? So in this instance, the 19 is going to be the base because the 7.8 comes down and touches 19. Okay? So those two are going to be the ones we multiply together. And when you multiply those, you'll get 148.2 yards squared. Okay? Now, some of these problems will look a little bit different on your homework, so if you're having trouble figuring out the base and the height, let me know and I can talk you through it. Okay? Okay, find the perimeter and area of the figure. So perimeter. Okay, now this is a special case of a triangle, and I like that I chose it. So we know we have a side label 27 centimeters and a side label 20.9 centimeters. But notice that one side is left blank. I need to find it. Well, notice I have these little tick marks here. Tick marks mean congruent. So if this guy's 20.9, that means this other guy is 20.9. So now you're thinking, well, what the crap's that 16 there for? That's actually your height. You need that for a triangle. So now we have a height. Which one's the base? Well, who's the height touch? It's 27, so that's your base. We'll use that in a minute. For perimeter, we just add up the sides. So we have two 20.9s and a 27. You add all that up, it's 68.8 centimeters. All right. Area, so it's 1/2 times the base of 27 times the height of 16. You type all that in a calculator. If you want, you can use parentheses. Doesn't really matter. You could use 0.5 instead of half. That's fine. But either way you type it in, you should get 216 centimeters squared. All right. Now trapezoids. So first let's do perimeter, and I know every side, so I just add them up. 9 plus 7 plus 5 plus 13 equals, when you add all that up, it's 34, and this would be millimeters. That is a tiny, tiny little trapezoid. Now area. So remember, for area of a trapezoid, we need the height and two different bases. So you're asking yourself, well, who am I going to let be what? It's kind of hard to tell. Remember, heights are always straight up and down. So 9 it cannot be a height because it's crooked. That means that 5 has to be the height because it's straight. Okay? Now remember, heights also touch the bases. So that means that 7 is one of the bases and 13 is the other base. Okay? And if you need to, you can rotate your paper so that you can rearrange the figure so you can see it in a different format. If it's sitting like this doesn't help you, you can always turn the paper. So now we use our formula. 1/2 times the height times base 1 plus base 2. So 1/2 times the height. And I'm using parentheses here, but remember this is all multiplication. 1/2 times height times base 1 plus base 2. You type all that in, we get 50 millimeters squared. All right. Last one for this video. So it's another trapezoid, but now notice this time we have something inside the trapezoid. So we will not use that for perimeter, okay? That is actually the height of this parallelogram. Or, not, I said parallelogram, have mercy. It's a trapezoid. I'm sorry, it's a trapezoid. And that 32.7 is its height because it's straight and it makes a 90-degree angle with this base. And actually with this other one, you could label it if you wanted to. That means this is base 1, this is base 2. You could alternate those if you wanted to. Doesn't really matter. 35s are just the other sides. We will use those in the perimeter. Let's start at 13. So 13 plus 35 plus 38 plus 35. You add all that up, it's 121. This will be meters. So area, we're going to do 1/2 times our height, 32.7, times base 1 plus base 2. You type all that into a calculator. You get 833.85 meters squared. Okay? So what we've done is as a recap, we've found perimeter and area formulas for 5 different straight-sided figures, which we call polygons. So we looked at a square, a rectangle, a parallelogram, a triangle, and a trapezoid. I need you to know all 5 of those and how to find perimeter and area for all 5 of those figures. Okay? It is so important that you know how to do this because they're going to put it all over the ACT, and it's very applicable to the real world. A perimeter problem, in real life, you could think about it if you're going to fence in a yard, or if you're going to put new baseboards around the bottom of your walls. That's a perimeter problem. Putting paving stones around a pool, that's a perimeter problem. An area problem, because remember, area is like space, so you could think of laying carpet down or laying hardwoods down, or how much area inside a fence would be. That's an area problem. There's so many applications of this in the real world, so this is why it's so important that you know this. So now remember, this is just part 1 video of polygons. Part 2 will also be posted, and that's all about circles. You've got to watch both videos. Okay? So if you're confused about this part of the homework, please let me know. And make sure you watch the other part.